Hi everyone, welcome back to my channel. So there are some requests from a few of the followers to about the interview questions. So I'm going to create a new playlist for the networking interview questions separately, and this is the first video of the series. And if you guys want to know like more interview questions and answers, then you guys can follow my channel and press the like button and subscribe to my channel. Okay, let's go to the today video. And today video that I'm going to explain about the packet walk uh, generally asked in an interview questions. If you are a new guy who want to get a job in a networking field, so mostly this question that you will encounter during an interview. And the first question they'll ask you, like they'll create a topology. They'll give some topology to you. Like consider this topology that I presented in front of you guys, and they will ask you like, I have already the topologies established and already every in my network, I have configured everything. Now I want to know like how a packet travels from one source to the destination. Consider like our source here is the R3, okay, and our destination is consider this is our source. R3 is the source router, and destination, let's say it's in the R4. Okay, now the packet has to travel from R3 to an R4. Okay, so what are all things that it will happen when I initiated a some kind of packet request? Consider like I'm forming an session, like I have a host PC here, a user is sitting here. Okay, also have another server or another user. Okay, so let's say I have a HTTP connection from here to here. So I want to know how the communication happens and what are all the fields that can change when the packet travels, and each and every hop on the router. So what are the fields will change and what will happen to the router when it receives the IP packet. Oh, sorry, when it receives the data frame. So that's the question they will ask you. So for that, first you have to like you can answer it like in this way that I'm going to explain. You can say first when you initiate, okay, from a PC, what will happen is there will be consider there will be a switch will be there in all the network. So first what happened is first route switch from the PC, it will send it to the default gateway. Okay, PC1 it will send it to the default gateway if they are in the different subnet. Okay, consider like the main way that I have told you, like the user is in different location, so they definitely it is in the different subnet you can consider. So now I'll check for the ARP on the PC. I'll send an ARP request for the destination MAC address, and I will resolve it and send it to my default gateway here. Okay, once I send the packet to the default gateway, so now what router will does in the first stop. Okay, so what router will do first, it will check what, it will check the MAC address. So what MAC address it will check? Okay, so MAC address that it will check is it whether the received packet's destination MAC address is same as the interface that connected to the receiving interface MAC address. So if this is correct, that packet will accept it. Okay, the packet will accept. Once it accept the packet, then it will check the Ethernet header, what type of packet it is. So if it is 0800, then it is an 8000, sorry, it is an IPv4 packet. In case of IPv6, this will change, it will be there in the Ethernet header. So then once it check the Ethernet header, then what will happen is it will de-encapsulate to find the destination IPv4 packet. Now it will check the destination IPv4 packet. So for that, it will what it will do, if the interface, it will check the first connected interface whether the destination address is part of the connected interface. If it is not, then what will do, it will look up the routing lookup, it will perform. It will do the routing lookup. Okay, once it does the routing lookup, what will happen is it will form a packet again. Again, it encapsulate. So what are the field that it encapsulate with is first it will the source IP and destination IP will not change, but now the packet is received here, so it has to put its MAC address as a source MAC address. So source MAC address will change. Okay, then it knows that to reach the destination, it has to forward the packet to the R1 now. So what will do is it will change the destination MAC address. Okay, then what will happen is then there is some field called TTL, time to leave packet. So this I will explain you what is the use of TTL and in IP and switching scenario in a different next video. Time to leave. Okay, so it will reduce the because it is the first stop, right? So from PC it came to this router. Now it has to deduct the TTL value. It will deduct the TTL value from 255 to 254, and if it is a plain packet, what does this is it just simply forward the packet after performing all this action. Okay, in case if the router is enabled for any change for QoS, consider they have the quality of service that we have a separate video, the CCNA playlist, you can check it out about QoS. For the it will change the QoS field also and the IP packet. Okay, then next what else that it will potentially change? There are other fields in the IP port that will also get changed. That is, in case if the link MTU is lesser than the received MTU, like the packet MTU, then what will happen is consider like here the MTU is lesser. What will happen to it will do the fragmentation. So when it does the fragmentation, it will mark the packet that it is a fragmented packet. So it has to change, and whether it's a first packet or it's a last packet. So the fragmentation bit will change on the IP packet. So what else? The next one that if we can think of, we have changed the source MAC address, destination MAC address, and we did change the TTL value. Like let me write, and we have changed the SRC source MAC slash destination MAC. Okay, source MAC changed, destination MAC changed. Source IP will and destination IP will not change, otherwise the packet will not reach. Uh, so TTL is changed and QoS is changed. In case if they configure QoS, yeah, QoS value bits will be changed. And in case the link has a lesser bandwidth, then the fragmentation will happen. So the fragmentation bit will change. So what could be the next bit that it maybe that there is a chance that it can change is if you can comment, you can comment if you think of anything. Otherwise, I'll tell you now. The next in the IP packet can change is the if they have enabled NAT, okay, then the if in case they have a static NAT, so there is a chance the based on the NAT whether they have the source NAT or destination NAT, so the IP address also will be changed in the IP packet because the NAT is enabled. Okay, these are the fields that can potentially change in the IP packet when a packet travels from a source to the destination. Okay, so let's consider this NAT is not enabled. Okay, and the link bandwidth all are correct. Okay, and it's there is no QoS in the network default. Okay, then normal scenario it will change source MAC and destination MAC and TTL value. See, the two things will change when a packet travels from a source to the destination. Okay, so this is the very important questions that you may get in during your interview questions. Okay, so this we will see it in the lab also, that I have already set up the lab. So let's go to the lab and so that we can see the answers. Okay, so this is the topology that I'm going to explain about the packet walk. So I already pre-configured the network. So what I'm going to do, I'm going to do a ping from R3 to R2, and I'm going to do a packet capture from R3, R1 and R2 interface, so that we'll be able to see what are the packets in the IPv, what are in the fields in the IPv4 packet changes, and what does the router do when it receives the packet. So these two things that we will see practically. So I'm going to do a capture. So exit interface E/1 on this router. Okay. So I'm gonna just filter with ICMP, so that I don't need like other I don't want to see other packets. So then next I'm gonna capture it on E0/1. Capture E0/1 again. Okay. The next is E0 slash sorry E0/0, I think. Okay. So I'm going to initiate a ping packet from R3 to R2 router. Ping. So first I'll check the routing table whether I have the route. So R2 IP address is 2.0.0.1. I have the route. So I'll be able to reach the destination. Ping 2.0.0.1 source 1. I need to check my local IP. Just a minute. Show IP interface. Okay. Ping 2.0.0.1 source 3.0.0.1. Okay. Now I initiate the packet. So I can see that ICMP packet here. It's been captured. So we'll discuss in separate video what are the fields in ICMP packet and how we get the request and reply in the another video. Okay. So this just explain the what are the fields that change in the IP field. Okay. So I have the IP request. Okay. So that this is the router that I initiated. Okay. Here you can see what are the fields. So as I said, once when it generates the packet, right? So it has the source MAC address and destination MAC address. So let's verify the source MAC address here. So show IP route 2.0.0.1 and it's learning via Ethernet 0/1. Show interface Ethernet 0/1. Okay. Now what is my MAC address is AABB33010. Okay, you can see that source MAC address is 3010. Okay. So the next router is R1. So we need to say it's setting the correct MAC address. Okay. Here show IP, show show IP route, show interface Ethernet 0/1. What is the MAC address for this? It is 1010 in the ending. So let me go through this. Let me go to the voice share capture. Yeah, here you can see it is 1010. So now the packet traveled from R3 to R2 with this as a source MAC address and this as the destination MAC address, but the source IP you can see is the same. It will not change. Okay. Source is 3.0.0.1 and destination is 2.0.0.1. As I said, so how it identify it is an IPv4 packet, because in the Ethernet field it will set 0 into 0 800. Sorry, I put 8000, but it's 0 into 0 800. Okay, so this is how it like identify it is an IPv4 packet. Okay, let's go into the IPv4. So what are all the fields that it will change? Now it says that version 4 and 25-bit. As I said, QoS, it's a default QoS, so there is no change in the default QoS. There is no field change here. Then when we go flag, there is no fragmentation. If it is a fragment offset, then it will change it to 1. As you can see, the packet is initiated from here, so the TTL value is saying 255. Okay, and it's a source and destination, and it's a checksum of the packet. Okay, now we have identified the packet travel from here to here. Now we will see the packet what received here. Second. Okay, so this is the packet that we received on the R2. Here we see this is an IPv4 packet, and is here you can see from which what is the source and what is the destination packet. From where it's received, this is the source and this is the destination. And here you can see it is 255 because it's in the receiving side, so it is 255, and there is no field has been changed because it's a received packet. Okay, now what we'll do, the third capture dot what we did, we did a capture here in Ethernet 0/0 on the R2. So let's open a packet here, open this packet. Let me check this. Here you can see the source MAC is different and the destination MAC is different. Okay, so this router's exit interface will be the source address of this packet, and this interface MAC address will be the destination MAC address, the packet that received on R2. So that we can verify it by logging into the router and check the interface. Okay, so show IP route 2.0.0.1. Okay, show interface Ethernet 0/2. Okay, so the MAC address is 1020. So here you can see, sorry, I checked the wrong IP. Okay, 1 second. Okay, check the correct router, the topology. It's on the R2. Sorry, I checked the wrong interface. It is ET 0/0 as per the topology. So okay, so the MAC address is AABBCC002020. AABBCC, you can see this is the MAC address on the R2. Okay, the MAC address is AEBB1020. So let me check because it has the load balancing enabled. Let me check this also. Okay, I'm checking this. Maybe I think I'm missing something. Okay. 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 Now we can see that this is the. I think I'm seeing the wrong packet. Let me quickly check. Okay. 0010000. Okay. 102,000. Okay, that is the issue in the topology. So okay. So it is receiving via the packet has been actually what happened is like I did a capture on this interface and this interface and here and here. So I just got confused. So like so now you can see that now you can see from the last packet capture that we did enable here. We see that okay. I need to look the not replay. Okay. Okay, I got it. So what happened is like what we are seeing is a reply packet. So I didn't notice this. It's not a request packet. So here you can see we just check the request and reply, but here we have started seeing the the reply packets. I was not able to capture the request packet. So let me do a capture and do the request. So what happened is, so we did initiate it here. We verified the source MAC address, destination MAC address, the source MAC and destination MAC. And here we are trying to identify the request packet, but the request packet has not been captured in the Wireshark. Uh, just because that maybe the request has come from this interface because I have enabled the load balancing on this router. So I just disable it so that we'll be able to capture correctly the request packet. Okay, so now again I'll just initiate a ping from here so that I want to show you guys. Okay, now we are able to ping and let's check the packet capture now in the router last route. Okay, now we are able to capture the request. So what happens in the topology, I did for some testing enable the like load balancing on this two links. So the request was going like this packet and reply was coming here. So that's why we are able to only capture the reply on this interface. Okay, now we have the request packet. Let's open it. Now we can verify the source and destination MAC. So now you can see the destination MAC that it received. So now the packet that we are seeing it here on this interface on the 0/0, the packet is forwarded from this router to here. So now we see this interface MAC address as destination MAC address and this interface MAC address as the source MAC address. That you can check. Here you can see that MAC address here. Also this MAC address in the source. C0110. Okay, and now we have identified that when the packet travels and there is no extra configurations is applied to the router to change the QoS or fragmentation is not happening and there is no NATing, then only the source MAC and destination MAC will change at the each hop of the router along with the TTL. So let's open and check. Now you can see the TTL is 254. So what it does when it receives the TTL here 255, okay, then when it forwards here, then it will reduce the TTL from 255 to 254 and send it here. Okay, so in an ideal condition, source MAC, destination MAC, and TTL value changes on the IP packet whenever it travels from one node to the another node, IP node in the network. So then this is the how the packet walks happens in the network. And next we just quickly tell you how a router forwards a packet when it receives it. Okay, consider now we did a ping test, ping, right? So what happened is, so the packet received from this router to this router, it received here. Then the normal process happen. It will open the Ethernet packet and check the source MAC. It will check the destination MAC, accept the packet, then de-encapsulate. Then it will check the destination IP address. When it check the destination IP address, it will check whether the destination IP address is part of any directly connected interface. That we have already shared this in the starting of the video. So it did not, the destination is not in any of the directed connected interface. The next steps it will does is it will check the routing table, show IP route. So it will check where the destination IP. So destination IP is 3.0.0.1, and then it's learning via this protocol, and the exit interface is Ethernet 0/1. So what it does is it again encapsulate with source MAC address as this exit interface MAC address. Okay, show Ethernet 0/1 as a source MAC address. It changes, and it does changes the TTL value. Then it will apply the destination MAC address via our protocol. It knows the directed connected interface MAC address also, IP address MAC also. So it does put the MAC address of the destination router, and then it sends the packet to the next router. So this is how you need to explain in an interview. Hope this video is useful for you guys. In next video we will see different topics with different questions. And do press like button and subscribe to my channel. Thank you very much for watching.